All right, everybody, welcome back. We are going to go ahead and get started in Unit 6, which is all about ionic bonds. Now, before we do get started, it's important that we cover a few things in review from last unit, which is going to be about molecular compounds. So we'll talk about Lewis dot symbols, the structures, and covalent bonding itself. Okay, so let's start with Lewis dot symbols. First, we need to draw the element symbol. We'll do this with fluorine. Fluorine's symbol is F. And then we need to figure out the number of valence electrons. Now, those are the electrons in the outermost energy level. And we can figure that out by either looking at the group number, so that's group 7 for fluorine, so 7 valence electrons, or we can write out the electron configuration, which I've done right here. And then we can add up the number of electrons in the highest energy level, which is 2, so that would be a total of 7 valence electrons. And then add each of those one at a time around the outside of our symbol, and that gives us our Lewis dot symbol for fluorine. Let's look at the characteristics of this Lewis dot symbol of fluorine. You'll see that there are these lone pairs. Those are pairs of electrons that do not participate in bonding, and we have 3 pairs of lone pairs. Now, we also have this single electron here. We don't want to have single electrons, so we'll fix that by pairing it up with another electron from another atom. In this case, will be hydrogen. When they are paired up like that, they are now called a bonding pair, and that's a pair of electrons that do participate in bonding, and they are shared. So what we've officially created is what's called a molecule, or the smallest unit of a substance that contains 2 nonmetal atoms or more that are covalently bonded. Okay. So when you sandwich 2 symbols together, we get what's called a Lewis dot structure, or we've also called them structural formulas in class. And those are pretty easy to convert between. So the structural formula, you're just taking any bonding pair, which we have one between hydrogen and fluorine, and you're turning it into a line. So you'll see that those lines do have 2 electrons in them. Okay, so now recall the octet rule, which tells us that all atoms in a covalent compound need to have 8 valence electrons around them, except hydrogen, which only needs 2. So fluorine here has 1, 2, 3, 4, 5, 6, 7, and 8. Now remember, there are 2 electrons in that bond, so we count for both of them. And then hydrogen also has 2 electrons, which satisfies its octet rule, even though it's an exception. Let's talk about that line. So this line is known as a covalent bond. But let's break apart this word, covalent bond. Co meaning shared, valent meaning the electrons in the outermost energy level, and bond being the thing that ties those 2 atoms together. So we sandwich all those together. We've got 2 nonmetal atoms that are tied together by sharing their valence electrons. So remember, it's important that you remember what the octet rule is. It says that every atom needs to have 8 valence electrons. It wants to be like a noble gas. And this also includes ions, which are charged atoms, and they become charged by gaining or losing electrons, so positive or negative charge. Okay, so let's take a look at oxygen. Oxygen, here is the electron configuration for oxygen. It has 6 valence electrons, because it's in the 6th group on the periodic table. It's got 8 protons in its nucleus, and I'm going to go ahead and put the protons inside the nucleus, as well as put them on my little chart here to keep track of how many positive charges and negative charges I have. I also know that I have 2 energy levels. So I'm going to go ahead and fill those energy levels with the appropriate number of electrons. And you can see here that I have 8 electrons total. But remember that I only have 6 valence electrons, and all atoms want 8 valence electrons, including ions. In fact, oxygen will become an ion once it gets 8 valence electrons. So we're going to go ahead and add 2 valence electrons. And when we do that, we actually change a lot about oxygen. It no longer has 6 valence electrons. Its electron configuration is different, and it has 8 valence electrons. It's also now called the oxide ion. It's an anion, because we've now added 2 electrons. So it is now negatively charged by 2. Let's compare the neutral atom with the anion. We added 2 valence electrons to the neutral atom to create the anion oxide. And that not only made it a negatively charged ion, but it also made the electron configuration look just like neon. And the reason why it looks just like neon is because we added those 2 valence electrons because we want to have 8 valence electrons. So even though we didn't change the nuclei, add any protons, it looks like neon's electron configuration. So we've been talking a lot about nonmetals. Let's talk about a metal, magnesium. It's element 12 on the periodic table, and it's in row 2 on the periodic table, which means it's going to have 2 valence electrons. You can also figure that out by looking at the highest energy level in the electron configuration. It tells you that there are 2. So I'm going to go ahead and place my electrons in my chart and in my Bohr model. I have 12 electrons, 2 on the first energy level, 8 on the second, 2 on the valence. And then for protons, I went ahead and put 12 protons in my chart. I will not put them in the model because they take too much space. So the octet rule tells us that atoms all want to have 8 valence electrons. Well, we only have 2 in magnesium, and that's a problem. We need to get to 8. So we could do one of 2 things. Add 6 or remove 2. We're always going to do the easier thing, and in this case, it's to remove 2. If we remove 2 valence electrons, we now have a positive charge on this atom. It no longer has 2 valence electrons. It now has 8 valence electrons because we've exposed the full shell underneath. We've also exposed the 2 positive charges of 2 protons, which means that this is now called the magnesium ion. Let's compare neutral magnesium with the cation of magnesium. They both have 12 protons because they're both magnesium, but their charges are different. And that's because neutral magnesium has 2 valence electrons, whereas the cation has 8. The reason why the cation has 8 is because we removed the 2 valence electrons in the neutral form, and that exposed or revealed the full shell of 8 valence electrons underneath. That made it look just like neon, which also has 8 valence electrons. Notice that the cation and neon have the same electron configuration because our ions want 8 valence electrons. So, in summary, all atoms and ions want to have 8 valence electrons. Whether you gain or lose electrons is totally dependent on what's easier. If it's easier to gain 2 electrons, you will gain electrons and add to a full octet. If you lose electrons, you will reveal the full octet in a lower energy level.